Well, Jack and Ollie are off entertaining their groupies, so I guess I'm left to unpack this customer amp that was just shipped to us. Let's open it up and see what's inside. Well, this is a little worrisome because there's no padding between the inner box and the outer box, so it's been thrashing around in here on the trip. So better open this inner box and make sure that nothing was harmed inside. It looks like this was packaged by UPS for transport. If that's the case, it's just another reason for me to boycott them. I've just never been pleased with their service compared to FedEx Ground, and this type of packing job makes me feel even more that way. This appears to be a Blackface Fender Princeton Reverb, but as you can see, it's more or less just thrown in the box with some of these airbags around it. This side has no padding, and there's a bunch of the airbags underneath, and I really fear that they might have crushed or damaged the grill cloth. Let me get it out of the box and we'll see. Well, amazingly enough, it seems to have arrived in perfect condition. Okay, I can see no external damage anywhere. Of course, I'll have to take it in and open up the back and check it out closely, but through no favors from UPS, it looks like it made the trip safely. Okay, we have the Princeton Reverb up on the workbench, and it is in astounding condition. Absolutely mint. Look at the gloss and perfection here of this control panel. Notice that the knobs have the Allen head set screw at 1. This is unusual. I'm not familiar with seeing all of these numbers. Normally you'll see patent design 68. Maybe this has something to do with it being a 1967 model. And as viewers have asked, this 68 doesn't mean the year. It refers to the patent document that covers certain aspects of the design and circuit. Look at the incredible grill cloth. Got a little age, just a little bit of patina to it, just perfect. It's exactly what you want. Flawless Fender emblem. Top is immaculate. Absolutely stunning condition. I did a video on a super nice 67 Princeton Reverb a couple of years ago, and I think this can hold its own with that one easily. Okay, this thing is absolutely spectacular. Thank God it made the trip in one piece, despite the inadequate padding. And as we can see, the rear view is every bit as wonderful as the front view. Every sticker's in position, perfect speaker plug, absolutely mint control panel. Rear Tolex is fabulous. Got the ubiquitous white spot, the original and obviously stomped on a bit foot switch for both reverb and tremolo, although they call it vibrato. It's like the original two-prong power cord. The owner wants a 3-wire cord installed. Looks like a set of ruby tubes. They left the 12AT7 and 7025 in place with the shields, and these are all ruby tubes, 6V6 and a 5AR4 rectifier and two 12AX7s with the shields. All in all, utterly spectacular. Let's pull the back panels, take a look at the serial number and at the speaker. Okay, we've got the upper back panel off, and we can home in here on the serial number. See, it's A16574, which puts it right in the middle of the 1967 Fender Princeton Reverb run. Okay, this would be the last of the Blackface Fender Princetons, and it appears that the speaker is going to be the original Oxford, 465, 643, which would mean probably the 43rd week of 1966 the speaker was made, which is goes along perfectly with the serial number, and the 465 means Oxford. Okay, apparently somebody at some time in the past has added like an auxiliary speaker, a wire to this, which is never a good idea because we know that two speakers in parallel have half the resistance of a single speaker. So this is not a good idea, okay, and will be removed. Alrighty, let's pull out the chassis and take a look. Also, we can take a gander here at the original tube chart, which shows QD at the bottom, Q being 1967 and D being the 4th month, April of 67. Okay, that means I was 20 years old when this amp was built. Very, very nice tube chart. Very, very nice amplifier. Okay, let's get that chassis out and see how it looks inside. You know, every time I remove a Fender chassis from a cabinet, I always think how much easier it would be if Fender had attached the nuts to the chassis instead of just leaving them loose in there so that you have to reach around behind components and try to either remove the nut or reinstall it. You can definitely tell this amp was pampered. Look at the condition of the metal plating. Absolutely flawless. The handle's so nice, it almost looks like a replacement, but I have a feeling, like everything else on this amp, it's just completely original. Perfect. Okay, the chassis is out. Let's take a look at it here. We got the reverb driving transformer. We also have the oxidation that I think is due to the probably cadmium plating of the chassis to keep it from rusting, and I believe this oxidation is toxic, so I will be sure to lick my fingers after touching it. All original transformers. You notice that the power transformer on this amp is rather conservatively sized, okay? These are not the most robust of power transformers, yet they seem to hold up pretty well. Okay, we can see an original production number here on the chassis. All in all, absolutely spectacularly original condition. You know, the beauty of amps like this, besides just seeing them making us feel good, is that if you're restoring one of these, as I did several years ago, seeing one like this up close really helps you to know what original looked like, okay, and is generally very, very helpful when performing a restoration of one. Now let's flip it over and take a look underneath. And now the standard drone flight over the interior of the chassis. We see up here the bias circuit, rectifier, output tubes, original can capacitor, all blue molded caps in this case. I noticed none of those yellow Astrons. Some of these might be questionable here, and with coupling caps they'll have to be thoroughly tested. But as you can see, and that one's sort of unusual, but it looks like original soldering. But as you can see, absolutely a pristine, just magnificently original chassis wiring, and all the assembly numbers and production numbers stamped are intact. It's just a joy, a pleasure, an honor actually to work on amplifiers of this age and quality. I'm doing an ESR test of the 4 electrolytic capacitors in the can, and every one of them is either 1.4 or 1.5. It seems like just a crime to me to replace this electrolytic can capacitor. I'm going to talk it over with the owner of the amp and see if he wants to roll the dice and keep it all original as far as can capacitor goes, or if he wants me to replace it. But I can tell you that this can capacitor is going to function perfectly. The only question might be for how long. Okay, it's been in here for what, 55 years or so, and we know that these things eventually will deteriorate and fail to function properly. But how many years has this thing got left in it? Might be another 10 or 20. Okay, so like I said, it's a real kind of an enigma of how you approach replacing completely original, fully functional components in an amp to either play it safe or to preserve the originality. I don't know. You know, I come down on either side of it, and I tend to leave it up to the owners. All the cathode bypass caps check out as being fully functional and in great shape, except for this one, which is throwing a rather high ESR value, and definitely this would have to be replaced. Now it's time to move the rear of the seat forward so that I can reach the pedals. Apparently the guy who built this car was like 6'6" or something like that, but I'm not. So you see that the rear of the seat's been removed, and we have a really nice steel backing plate here to work with. This is the cushion. It's probably about 4 inches thick, and as you can see, it's held in at the top with 3 snaps. Now my plan is to build a seat backing out of wood that is spaced about 4 inches out at the bottom and about 1.5 inches out at the top, so that you have a nice kind of a recline, but down here your hips are far enough forward that you can reach the pedals. By you, I mean me. Alright, here's the lower seat back spacer. I use the 4-inch by 3/4 inch plank as a flange to hold it to the rear, so this gives me the spacing of close to 4 inches out here. And then we'll mount the 2x4 up here and then put in that piece of plywood, lay the cushion against it, and see how it feels. I decided to make the upper seat support into like a little narrow package tray. So I cut this at an angle so that it is perfectly horizontal when it's attached to that sheet metal seat back. Then I made 3 brackets which will be bent at the proper angle, and drill them, and now I'm going to screw these into the wood, and then these will go into the sheet metal to hold this in place. Okay, here's that upper package tray with the brackets properly bent and attached, and now we're going to install it here on this sheet metal seat back. Okay, the upper and lower support boards are in place, and now I'm going to install that piece of flat plywood against. Then as a final touch, before I install the plywood back here, I put a fairly heavy layer of indoor-outdoor carpeting that will dampen the vibration and rattle from this flat piece of sheet metal. Now I'm ready to install the plywood. The panel has been installed, and now it's time to upholster the top here of this shelf, and I've got a matching red vinyl to match this, so it will all fit together. Well, I applied the contact cement to that package shelf and wrapped it with a matching red naga hide, then installed the 3 snaps, snapped in the seat, and as you can see, I think it all looks pretty darn nice. Looks like it came. Time for an update on the 1967 Blackface Princeton. The 3-wire power cord has been installed through the original grommet. The ground wire is bolted to the chassis. The ground switch has been bypassed, and the primary circuit has been properly wired so that the hot wire passes through the switch and the fuse before going to the power transformer. The replacement CAN capacitor has been ordered and should be here in a couple days. Meanwhile, all of the cathode bypass capacitors have been replaced. There are a total of 6 of them, 2 doubles, 2 singles. I think this one must have been replaced. It's a Ducati capacitor, and the only Ducati I know of is an Italian motorcycle. So it looks like there had been a little bit of work done on this, but not much. Okay, also down here in the bias circuit, the diode has been replaced with a much more robust diode and the 50 at 50 electrolytic capacitor has been replaced. We don't know about the status of this resistor right here, if it's appropriate for the biasing of the output tubes. We'll have to find that out after the amp is up and running. Next, we'll clean all the pots and all of the tube sockets. To do this pot and tube socket cleaning, I've been using a different product. It's Neutral Control Cleaner. It even has an adjustment for the amount of spray that comes out each time you push down the button. I've had this for several years and it continues to function just beautifully. I have been having trouble with the delivery methods of the deoxit products, both of them. The chemical is just fine, but with this one, every time I try and use it, the top falls off and then the fluid just runs down the can. And on this smaller can, about 3 times out of 4 when I push the button, nothing, as you see, nothing comes out. Okay, then after about 3 dry runs, all of a sudden it does squirt out. So you can go down the line and every 4th pot is going to get cleaned, which just isn't acceptable. So like I said, the chemical's great, but their aerosol delivery methods leave a lot to be improved upon. Well, after several days, the can capacitor showed up in the mailbox, and I think this might be a nice time to have a brief discussion about the difference between replacing the can cap or replacing the capacitors within the can cap with 4 separate electrolytics underneath the chassis surface, hidden away inside the circuit. Back when I worked on jukeboxes, can caps were easy to get. I could order a whole case of Mallory can capacitors for like, $5 or $6 a piece. Now they're much more expensive. These are made, I understand, with the Mallory equipment. Somebody has restarted manufacturing these, so they are now available to us. The problem being they are rather expensive. By the time you buy this and pay for the shipping, it's probably over $40 for this cap, whereas we can get these caps are probably around $10. So this will increase the price of the restoration process and would be a little neater on the circuit side than having 4 new capacitors added. But on the other hand, on the exposed side of the chassis, leaving the original cap makes the amp have complete original appearance, externally at least. The customer in this case said he preferred the can cap replacement and was willing to pay the difference. So let's go ahead now and get the chassis turned up on the workbench, and let's replace this cap. One issue with replacing can capacitors is that at least 2 of the tabs are usually heavily soldered to the chassis, and a normal soldering iron or even a soldering gun will have a hard time melting all of this solder so that you can lift the tab and push the can capacitor out of the chassis surface. So my solution to that problem is that I use a great big honking Weller SP80 soldering iron here that's really more suited for doing stained glass work, but I can assure you that it will make short work of these big lumps of solder here holding the can in. Okay, I've got the big Weller soldering iron here and a solder sipper. So let's start melting and removing those solder puddles. And eventually we can melt enough solder to be able to actually lift up the tab like so and release the can. Then using the same method, I release this tab and lift it up. Now I'm going to unsolder the leads to the 4 capacitor contacts in the can cap. Since all 4 are 20s, I don't really have to pay attention to what lead connects to what wire. But if this were a 40 and a 20 and a 10, you would have to draw a little map or mark your wire so you're sure that they go back to the right terminals. Now using a conventional soldering gun, I've released all 4 of the wires from the terminals, and now I'm going to go in with the iron and heat up this tab and pull on the capacitor and drop it down on this side, then heat up over here and drop the cap completely out of the chassis. Of course, before I do that, I'm going to lift these tabs up also. Alright, with a little additional heat, the cap came out of the chassis. Let's compare the original to the replacement. Now, I believe you can order replacements in different heights, so you might be able to match the size and shape of the original a little closer than this one. But as you can see, they're definitely in the ballpark as far as physical size and shape. Okay, now I have the new cap in place. I bent over the unsoldered tabs to hold it in place, and then I'll bend over these and solder them to the chassis to ensure that the can cap is properly grounded. Okay, the soldered tabs are pushed down, and now it's time to solder them in place. Then using our Husky soldering iron, we will very carefully and thoroughly solder the lug down to the chassis surface, repeating the process with the upper lug. Okay, I clean away the melted flux, and now we have a nice firm, absolutely rock solid joint between the can and the chassis. Now it's time to reattach the wire leads to their respective terminals. Alright, the can cap now is thoroughly soldered in place, and all the leads are soldered to the proper terminals. From the chassis side, everything looks pretty well original. From the outside of the chassis, to anyone who knows what they're looking at, they'd realize that this is a replacement cap. But I don't think that would be the end of the world. To be honest, if I were buying an amp and saw this, I might think that was a positive feature, that I wouldn't have to pay the price or do the work to replace the can cap. Now that these replacement cans are available, I'll probably start incorporating them into more of my circuit restoration work. Alright, the electrical work now is almost complete. Put the tubes back in place. Let's flip this jewel over, hook it up to a speaker, and see how it sounds, and also bias the output tubes, or at least check to make sure they're properly biased. And also maybe tune up the tremolo if needed. Alright, the amp is plugged into my new and improved and utterly magnificent solid oak current limiter sent to me by a very generous viewer. Next we have to connect the, I'll set the cabinet here so we can connect the reverb tank and the speaker to the chassis. The speaker has been divested of that really poor idea of having a parallel auxiliary speaker, and it is connected to the chassis, and the 2 shielded reverb cables are plugged into their proper sockets. Well, we're ready to go now. I'll go get a guitar, plug it in, and strum a few chords, and we'll see how this sounds. Okay, we're plugged into channel 1, volumes at 2.5, treble and bass are at 50%. Reverb, speed, and intensity of the tremolo are both down at minimum settings. So far so good. It's absolutely dead quiet, no trace of hum. Really good typical Fender Princeton bass and treble clarity. Let's try the reverb now. We'll crank it up to, let's go to 5. Wow. Now let's try the reverb at 3. After listening to Silvertones for so long, that's a pleasant change. Let's crank it all the way up just to be silly, okay, where you'd never put it, and let's see how that sounds. Well, typical Fender reverb, about as good as it gets. Now let's try out the tremolo. We'll go to a speed of 5, an intensity of 5. Well, that sounds pretty good. Let's try an intensity of 10. To me, it sounds a little wimpy. You know, I have a really quick fix for that. I'll show you. And I think we can get an intensity that you just heard at 5 and a whole lot better tremolo at 10 with this modification. Let me show you what I do. For those of you who aren't really adept at reading schematics, I'll show you the resistor here on the eyelet board that I'm going to jumper. It's this one here. It's a 1 megohm resistor. It is just to the right of the 3 tremolo capacitors, these discs. It's just to the right of them, and it is pointing right up here to the screw that holds in the 1, 2, 3, 4th 12AX7 tube base. This right here, this 1 meg, is the one I'm going to jumper. Now for those of you who would like sort of a mild improvement in your tremolo intensity, you can parallel in another 1 meg resistor, which will give you 500K total net resistance across that junction. For tremolo hounds like me and the owner of this Princeton, we're going to jumper in a 500K resistor, which will bring the net resistance down below 500K. Okay, so let's try a with and without and see what you think of the change. Okay, now with our parallel resistor, I'll turn this up to 5 on the intensity and 5 on speed. We'll also turn up our volume to the same 2.5 that it has been. Okay, let's see what you think. Now to my ear, at 5 now with the parallel resistor, we're getting maybe a little more intensity than we were getting with 10. Now just for laughs, let's crank it up to 10. And the tremolo now is so intense, you'll hear a very faint beating in the background. That's just part of the fun, okay? If you really want a seriously intense tremolo, hear it? Tiny little heartbeat in the background. Now what I'll do is strike a chord, let you hear what the tremolo sounds like with the parallel resistor. Then I'll disconnect it and strike another chord. You'll have a direct side-by-side comparison. As you can see, the difference is just huge. Now you can fine-tune your own tremolo to what maximum level you like simply by picking the parallel resistor value. I wouldn't go much lower than 500K, but that's up to you, okay? Just don't short that junction, okay? But now I'm going to go ahead and hardwire in 500K parallel resistor, and I believe we're pretty well done with this amp. And it will be time to turn it over to Jack and Ollie to play a couple familiar tunes for us, and then it's in the box and back to the proud owner. Now let's take a look at the biasing of the 6v6s in this Princeton Reverb. First, we see that the resistance of the two halves of the primary winding of the output transformer are very similar. We also see that the voltage drop is very close. The plate voltage is 404 volts DC, and the plate current calculated by dividing this number by this number is almost identical, 32 milliamps for one 6v6, 32.7 for the other. So far so good. But when we multiply this plate current times this plate voltage, we see that the plate dissipation is a little bit high. Not much, but just a tad. It's around 13 and 13.2. Now what I'm going to do is increase the value of the biasing resistor just a little bit. Okay, and that way less of the biasing voltage will go to ground and more of it will go to the grids of our output tubes and lower their plate current and plate dissipation just a bit. Now one last thing too I want to say is this is the first set of matched Ruby tubes that I've ever dealt with, and boy are they matched. This is wonderful. This has gained respect from me for Ruby tubes and their tube matching. So let's increase that resistor just a tad and see if we can't get these plate dissipations down below 12. By increasing the bias resistor from 24K up to 25.5K, you see that the new results are lower voltage drop, higher plate voltage, plate current is reduced a bit, and the plate dissipation, they agree beautifully, and they're both under 12 watts. So this is a nice conservative biasing. Well, I guess that's about it on this video on the really nice 1967 Fender Blackface Princeton Reverb. I hope you enjoyed the video. I wanted to, as I always do, take a few moments to thank the Patreon patrons and PayPal contributors. Any of you who would like to join them will find links in the video description which will enable you to do so. So now let's head out to the workshop to construct some baffles for the Model A rat rod, install them, and then fire it up and see how it sounds. I hope you like it, and I hope you stay tuned for future videos. Thanks so much. Bye for now. Well, today's job is going to be to make baffles to try to quiet down this ungodly noisy exhaust system. First, remove the 4 Allen screws that hold the deflector off. Then I went and bought a piece of exhaust pipe and run it into where it stops right here and cut it off, and with about that much protruding. Then we're going to make a flange here, kind of a donut flange, okay, inside and outside diameter flange that will hold this in place with these 4 bolts under the deflector. Naturally, I don't have a metal cutting hole saw that's exactly the right diameter, so I just did the old-fashioned trick with drilling holes all the way around the inside perimeter of the hole for the pipe. I've had to cover the car up because it's starting to rain, but that won't stop me. Cut out the circle in the middle of the steel plate that will fit snugly around the exhaust pipe. Then press the disc of metal on tightly and use the Sharpie to draw all the way around using the header flange here as a guide, and then we'll get a perfect line to show us where to cut and grind to make the outer circumference of the disc exactly the right size to fit the header flange. I guess it's time to change the disc in my cutoff wheel. Now that the disc has been properly trimmed so that it fits the flange exactly, I'm going to push it up real hard and use the marker to mark the holes in the flange for the bolts to go through. Alright, the 4 bolt holes have been drilled, and 8 small vent holes here have been drilled to allow gases that pass through the baffle and get trapped here in the chamber between the baffle and the wall of the exhaust to escape. Next step, we bolt the flange and pipe in place and spot weld all the way around the perimeter to hold the two together. And then the final step is we drill great big holes all over this thing. Just turn it into Swiss cheese. The more holes, the better. Then I'm going to wrap it with fiberglass, slide it in place, and then bolt the deflector and it onto the header. As you can see, I'm just using the type of fiberglass that you put up in your attic to insulate your house, wrapping it to match the taper of the header pipe, and then I'm going to insert it in place and bolt it down. Alright, it's all packed and the baffle slid in place. You can see the pink insulation here poking through those holes. Now it's time to bolt on the deflector. And then voila, the finished product. Now we'll have to start it up and see what kind of racket this makes. Well, it's got a nice lope and I think a tolerable exhaust note. Not as loud as a lot of Harleys I've heard. So I guess it's time to go to the car show.